Hi, I'm Jason Brozen, Leaf Safety and Technical Trainer here at Tyndale. Welcome back for another episode of the 70E Made Easy. Today we're going to talk about 120.6, steps 1 through 4, which is how to establish and verify an electrically safe work condition. There are 8 steps that need to be followed in order to do this. I'm going to cover 4 in this video and then in the next 4 in the next video. So these 2 videos might be a little bit longer just to make sure that we cover all the material. Also, to be clear, this is not an instructional video. I'm going to tell you what the 70E says, but you will have to get into your own electrical safety program and your procedures to de-energize equipment at your specific job site location. I also want to make clear that creating an electrically safe work condition, an ESWC, is energized work. You will need to understand your policies and procedures for working energized. Please note that the checklist that we're going to cover today is a minimum standard. There might be more processes required to ensure safety in your specific location at your facility. I cannot stress enough how important checklists are. Pilots have checklists, doctors have checklists. Your job is no less important or dangerous, so have one. All right, now let's get into it. Step 1 tells us to determine all possible sources of electrical supply to the specific equipment. Check applicable up-to-date drawings, diagrams, and identification tags. It's important to have an understanding that it's not uncommon to have multiple sources of power in a single piece of equipment. A few examples might be transfer switches, right? You've got utility power, you've got generator power, etc. Or control stuff, control cabinets, MCCs, etc. You can have multiple sources of energy and power in those enclosures. It would be like killing one rattlesnake in a den of rattlesnakes and calling it good, right? Not a safe bet. You can use one lines, you can use panel schedules, you can use schematics, blueprints, or stickers on the equipment, right? Your incident energy stickers. It's really whatever you need to use to keep yourself safe in each situation. Step 2 tells us that after properly interrupting the load current, open the disconnecting devices for each source. An example might be, say, a motor control center. You wouldn't want to turn off the main breaker on an MCC without turning off the individual loads. You want to click off the individual branch loads, then kill the main, do your work, turn the main on, bring that piece of equipment on slowly but surely. Operating a main switch under load, even if it's load rated, is never a good idea if you can avoid it. This can increase risk of damage to the switch contacts, as well as a possible arc flash. All right, moving on to step 3. Step 3 tells us that wherever possible, you need to visually verify that all the blades of the disconnecting device are fully open, or that draw-out type circuit breakers are withdrawn to the test or fully disconnected position. Here's an example of why that's important. If you just shut a disconnect off, lock it out, and then go downstream to do your work, you could be shocked or killed by this oversight. Visually verifying it is a very important step. It's not always possible to visually verify, so it's also important to understand that to open a disconnect and visually verify will possibly require arc flash and shock PPE. If you can't visually verify, then you need to make sure and follow through with all your testing procedures. Finally, for this video, step 4 tells us to release stored electrical energy. This can be in the form of batteries, capacitors, or even in the form of inductance. Some equipment can take a bit of time before it's safe to work on. Variable frequency drives, speed drives, VFDs are a good example of this. If there's not an electrical drain, you could be shocked by the capacitors in that equipment. All right, so that wraps it up for the first 4 steps of this video. Stay tuned for part 2 of 120.6, which is going to cover the last 4 steps of the ESWC. We'll see you next time. Stay safe out there.